Hi, my name is Emma, and I'm very honored that I won this prize, and I'm sorry that I couldn't be here today. My project is called Analysis of the Possibility of Using Radar Data Statistics for Artificial Rainfall Simulation. And the aim of the project is to describe rainfall based on high-resolution radar data. We know that extreme events at a very local scale can cause floodings, and yet we often model rainfall with the same intensity over an entire area, for example with a CDS. So if the left picture symbolizes how we model rainfall today, the right image shows radar images of a storm moving over the catchment for the same area. And as we can see, I hope that it's quite clear that there's room for improvement in describing rainfall in a better way. So this project has analyzed the possibilities of using radar data statistics for artificial rainfall simulations useful in urban hydrology. The case area is a 38 times 48 kilometers square around the catchment of Wupper. And the radar data is from the Wupper Association, and I've looked at 13 years of radar data from 2000 to 2013. So what I did in this project was that I selected a number of extreme events based on an extreme events selection, and then I used a spatial extreme events characteristic to describe these events. I applied 3 different statistical methods in order to come up with a preliminary guess or suggestions for which variables to use in setting up a weather generator which describes rainfall spatially and temporal. And the project did not set up a weather generator, so these are the preliminary steps. So I used 2 different kinds of extreme events, 1 hour and 24-hour extreme events, 1 hour to catch the thunderstorms, and the 24-hour extreme events to catch the longer storms. And I sampled a total of 39 1 hour and 39 24-hour extreme events. And the sampling method was that I sampled the extreme events from 1 grid cell in the middle of the area in order to use the same statistical terms as we do when we use rain gauge data. And if we look at the extreme events sample, we can see that the 1 hour extreme events are mostly in the summer, while the 24-hour extreme events are more uniformly distributed, which correspond quite well with the 1 hour extreme events. We expect these to be convective events, the thunderstorms, and the 24-hour events to be the front storms. Another thing we did was we looked at the extreme events characteristic with the spatial correlation, where we looked at the spatial correlation between extreme events in pair of grid cells as a function of the distance between the grid cells. So the further away that the 2 grid cells are from each other, which are compared, the less extreme events they have in common. And as we can see, rho decreases faster for the 1 hour extreme events than for the 24-hour extreme events, which again give us this idea that the 1 hour extreme events are local, small thunderstorms, while the 24-hour extreme events are spatially larger events. So we applied these 3 different statistical methods to the data set with the extreme events characteristic. And one of the methods was the clustering analysis, where we used a predefined number of 4 clusters and looked which information these clusters gave us. And what we can see is that these clusters actually can be described with some well-known event types. So we have the severe convective events and convective events, then we have convective events within a front system, and then at the end the front system. And we can see that there is an increase in extremity the further we go to the left corner down here. So what the conclusion was on this project is that the data is able to describe rainfall at a grid cell level, and we have 16 physical-based variables which can be used for extreme events characteristic. There was an indication between 5 and 9 dimensions to describe the data and the variability in the data, and we identified 4 different types of extreme events. a combination of these three statistical methods, where I have only showed the clustering analysis today, is that this can be used for as a first guess on variables for a future weather generator. I hope you enjoyed. Thank you.